This is the first topic for the midterm period, and it talks about layout planning models and design algorithms. This slide talk about layout alternatives. First and foremost, when you are doing a layout alternatives, please consider uh, that you are talking about a, a process map. Let's say, for example, you have three processes, A, B, and C. You will create different choices of the layout that is conducive for the storage of materials, for the dimension of how big or small your machineries and equipments are. Second, the number of personnel that can be accommodated on each of the processes. The material flow system, it should not be duplicated. It should not be multiple. It should be a, a material system flow that is efficient and effective. You should also consider the storage of the materials. So when you are doing a layout, you must ensure that all the important factors are captured in your drawing, in your diagram, in your process mapping, so that the layout uh, will serve uh, and be efficient in terms of the material flow patterns and the physical relationship between each of the activities. And always remember that your layout should have many choices. Basically, three choices is good enough. Let's go on recognizing that the layout ultimately selected will be either chosen from or based on one of the alternatives generated. It is important for the facilities planner to be both creative and comprehensive in generating a reasonable number of layout alternatives. This paragraph means that if you are a facilities planner and you are accountable for layouts, please invite all the key players or functional departments so that you can capture the ideas, the needs, wants, and requirement of each of the departments, like for example, quality control, inventory, production planning and control, the operations and manufacturing department, the engineering, the maintenance department, especially if they are going to conduct maintenance. So you must have a good facility layout, no, for the movement of the maintenance personnel, movement of machineries and equipment. If there is a battery powered forklift or any conveyorized system or any material handling system, which is very important in material flow system. So invite this functional department so you can capture the essence of doing a layout, and please ensure that there are alternatives or choices these people are going to choose. And the next is the facility layout. There are two types. First, the block layout and the detailed layout. Block layout, which show the locations, shape, and size of each of the departments or functional department or process department. And the second is the detailed layout. This is the very comprehensive layout, no? Which shows the exact location of all equipment, workbenches, storage areas within each department. So, uh, if you this slide is very important to your final output because uh, the blueprint is a confidential document and a proprietary document and very sensitive. That is why it is not being shared by other or mostly of the companies. So what you are going to do as your second alternative is to do a layout. You do a block layout and you do a detailed layout of the facility or area in the production or any part of the operations that you need to do continuous improvement or development. In this slide, we talk about the four types of planning departments. We have the fixed material location department, we have the production line department, we have the product family department, and we have the process department. And to better understand this, we should have an schematic explanation of each of these departments on the next slide. Let's talk about this slide, the production line product department. You can see here on this side, that's the store, which means the raw material storage warehouse. This one is the finish. There is one and there is two uh, types of warehouse. This one is the raw material warehouse, and the other one is a finish goods warehouse. You can see it here that raw materials uh, is fed to each of the different processes, and it is linear and it goes to a common final assembly, this one. So this is line 1, it has 4 processes. Line 2, it has 3. Line 2, line 3 has 2 processes, while line 4 has 3 processes. And all the work pieces are will be in one common area, which is the final assembly. Let's talk about the fixed product layout. Here, what is endearing is there is a common point where all the different processes are joined together in a single area. And this is the final assembly and it goes to the finished goods warehouse. Again, this is the raw material warehouse. The next is the product family layout. Here, what is endearing is that it is clustered. No? It is basically clustered. This one, this one, this one, and this one. There are 4 clustered product family layout. From raw materials, like for example this one, from raw materials, this line goes to this product family layout, while this one, it has 2 points. One goes to a continuous process and this one goes directly to the finished goods warehouse. So there is a product family here that the product needs more processes before it goes to the assembly and warehouse. And the last one is the process layout. In the process layout, these are series. Uh, uh, some companies like semicon industries do a process layout because uh, each, for example, you have the process here. The workpiece is needed to be processed on this second process, and the output of this is processed here. So this is a process layout. Let's talk about Apple's plant layout procedure. There are three types of plant layout procedure integrated in this slide. One is Apple, the second one is Reed, and the third one is Muther's plant layout procedure. The concept and principle are basically the same. Let's talk about Apple's plant layout procedure. Here you can see that all of these things are planning. Okay, so you plan how the facilities is going to be laid out, the connectivity, the interrelationship, and you are going to in integrate and sync in all the five M's, right? So these five M's are your men, material, methods, machineries, and money. So you are going to use these five M's as your inputs so that you can basically create a plant layout. So let's talk about here is the data gathering, and you design the efficient process. You talk about methods. Uh, you talk about material flow pattern. You consider the material handling, uh, the general concept. All right. Here you calculate how many equipments are needed. So you talk about machineries. Here is the workstations that are needed by your workers. You talk about men. You select again the material handling equipment and you talk about the materials. Coordinate groups of related operations. You talk about process, methods, and the activity interrelationship, storage requirement for the materials. And number 12, you talk about access to preventive maintenance. How many space are needed in order for the uh, requirement of space for these 5 M's. And you talk about again the building type. You construct the blueprint of your layout. You fine tune, discuss with all the functional areas concerned, no? And in order to create a final product, in order to gain and get approval and implement the final layout. What is critical here is course, these are all in the planning. After planning, you go to implementation of the plan, and then you evaluate the plan and continuous development or continuous improvement, and you go back again to the plan, right? Another example of a plant layout procedure, this is from Reed's plant layout procedure. Again, our basic knowledge here at everything here is under the planning stage. No? So here you talk about the product or the product that is to be produced. No? And of course, after analysis, according to Reed, you consider now the 5 M's. There is the process, which is the method. You prepare the layout, planning charts. Later on, you will see the example of the chart here. And you determine the workstation that is needed by the personnel. You analyze the storage area, which is for the materials. Establish minimum aisle width, again, requirement for machineries. The office needs and wants. You consider the personnel, the survey, the plant services needed, and then the future expansion. What is endearing here is future expansion was considered. Uh, the salient point of Reed's plant layout is that it incorporates the flow process, no? The standard times for each operations, the machine selection and balance, as well as manpower and the material handling requirements. This is the chart that was emphasized by Reed. You have the description, you have the interrelation of the activities, the machines, the manpower, and the handling requirements. So everything here is under a planning chart, no? Of Reed. No? This is a planning chart. Just to capture the essence and the quantities that are needed. No? In this slide, there are stages. You analyze, and then there is the evaluation, and then there is a search for alternative. Okay. In Muter's systematic layout, it incorporates a process map. So there is a start and there is an end. So the flow of the arrows is going down. So you can see it's like a fishbone diagram, right? See? Space requirement, relationship diagram, activity relationship, the flow of materials is basically under the analyze stage. And then the search is the space relationship diagram, modification, and the practical limitation. And this one is the evaluation. No? Evaluation is related to planning and not under evaluation stage. No? Remember that this system layout is all in the planning. What is emphasized here is evaluating the best choice of the layout. A Another tool For identifying a layout. Uh, this is from a department to another. Uh, this from to. Basically, what is important here is the material and the distance matrix. In order to find this answer, here is the you have to pairwise and exchange 10 and 1, 15 and 2, 20 and 3. There you go. 10 and 1. There you go. 5 and 2. So, how is this going to be layout? There you go. That is 5 and 1. No, you multiply those and you get the final answer of 125. Simply, this is a just a bonus, but typically graph base is not included in this chapter. Thank you.